Welcome to the Deep Dive, the show that helps you cut through the noise and get straight to what you really need to know. Today, we're taking a deep dive into a corner of technology that's brimming with potential, but also, well, some surprising realities. AI agents. Now, you've probably heard a lot about AI, maybe used some chatbots. But what about AI that kind of thinks for itself, sets its own sub-goals, and, works continuously towards a big objective without you constantly telling it what to do step by step? That's the fascinating, maybe slightly weird realm we're exploring today.
It is fascinating. A potential game changer, for sure. But it's not without its initial stumbles. Our sources have revealed something quite startling, actually. Current AI agent deployments, well, they often face staggering failure rates.
Staggering how?
We're talking about top models like OpenAI's GPT-4o and Meta's Llama 3.1405B, failing over 90% of office tasks in real-world scenarios. Over 90%.
Wow. Okay, 90%, that's huge. But you're saying don't let that stat make you think it's all hype.
Exactly. Because these same sources, they also illuminate the immense potential, the upside of these autonomous systems, and crucially, how to get them right, how to actually make them work.
Right. So our mission today is basically twofold. First, unpack why these failures are happening, what's going wrong, then explore the incredible real-world applications where AI agents are starting to make a difference. And then here's where it gets really interesting, maybe a bit mind-bending. We turn our attention to this revolutionary concept, the decentralized AI agent.
That's where things could get really transformative.
Yeah, discovering how combining AI with technologies like, say, blockchain and just smart human oversight might be the key, unlocking maybe an unprecedented era of efficiency, innovation, but also we need to navigate the complex ethical landscape these powerful tools bring with them.
Okay, so to kick things off, let's clarify what we really mean by an autonomous AI agent. Because like you said, we're not just talking about your typical chatbots or simple AI tools that do one specific thing.
Right. What's the fundamental difference? Paint that clearer picture for us.
Well, think of it this way. A traditional chatbot, it's mostly scripted, right? Rule-based. You ask X, it gives you answer Y.
Pretty predictable.
Very. But an AI agent, it's more like giving the AI a big, broad goal, like optimize this entire supply chain. And it doesn't need a step-by-step to-do list from you. It figures out that list itself.
It makes its own plan.
Exactly. It adapts, learns, prioritizes tasks, maybe reprioritizes based on new info, all working towards that ultimate goal, continuously.
So these are much more sophisticated software entities. They're learning constantly, pulling information together.
Right. Integrating info from various sources, making multi-step decisions to achieve those broad objectives, ideally without constant human hand-holding. They use advanced machine learning, deep learning, reinforcement learning to really understand context, remember past interactions, and adapt dynamically.
And you can sort of visualize it like a loop.
Yeah, precisely. It's a continuous cycle. Initialize the goal. Create tasks. Execute a task e-store, results in memory. Collect feedback. Generate new tasks based on all that. Prioritize those new tasks. Pick the most important one. Execute it. Iterate. Over and over.
It sounds incredibly powerful, and I guess the potential is there. But that reality check we started with, those failure rates, let's circle back to that.
We have to. It's jarring. OpenAI's GPT-4o failure rate of 91.4%, Meta's Llama 3.1405B fails 92.6% of office tasks. That's a critical statistic for anyone, any business looking to actually deploy these things right now, isn't it?
Absolutely. You wouldn't deploy something that fails 9 times out of 10 for a critical task. So why? Why are they failing so often? What are the big mistakes people are making?
Well, our sources point to several critical errors, especially from organizations, maybe startups, really eager to jump on the bandwagon. One huge one is just limited testing.
How so?
They deploy agents after only testing them in nice, clean, controlled lab environments. But the real world is messy, unpredictable. That's where the weaknesses show up.
And that leads to?
All sorts of problems. Customer-facing agents giving out wrong information, internal automation messing up data, maybe even corrupting it, development agents potentially introducing security holes, and often things like ethical considerations, bias detection, safety checks, they get overlooked in that rushed testing phase.
So the solution isn't just more testing, but better, more realistic testing, like simulating the chaos.
Exactly that. Comprehensive testing protocols covering functionality, sure, but also all those weird edge cases. Bias detection is crucial. And real-world simulation before you go live.
Okay, what else? What's another common trap?
Underestimating integration complexity. This is a big one. Companies get excited about what the agent can do as cool capabilities, but they overlook the nightmare of actually connecting it to their existing stuff, business processes, databases, especially older legacy software.
Ah, the legacy systems. Always a headache.
Always. It can take months, sometimes longer, just to get that plumbing right. So the advice here is a thorough integration assessment before you even pick an agent.
Makes sense. Choose one that plays nice with what you already have.
Right. And budget enough time and, frankly, money for that integration development. It's not trivial. Then there's the issue of inadequate human oversight and governance.
Assuming the AI will just handle everything. The set it and forget it dream.
That's the dangerous assumption, yeah. Automation doesn't mean humans are totally out of the picture. Agents will encounter situations they can't handle or maybe make poor decisions. Without governance, without human oversight, they could violate company policies, legal requirements, even ethical standards.
So you definitely can't just let them run wild.
Absolutely not. You need realistic expectations. Plan for gradual improvement. And crucially, keep humans in the loop, especially for critical approvals, interventions. Our sources strongly suggest these hybrid models combining AI agents with expert human oversight are the way to go. Get the efficiency of automation, but keep the human strategic thinking and problem solving.
Okay, what else trips people up?
Choosing the wrong AI agent. There are hundreds out there now. It's easy to get swayed by marketing hype or just pick the most popular name, but you really need to analyze your specific business needs first. Often, a specialized agent will massively outperform a generalist one for a particular job.
It's like using a dedicated customer support bot instead of just a generic chat bot.
Precisely. Fit for purpose, not just flashiness. Analyze requirements, evaluate based on functionality, compatibility, and, total cost of ownership.
Yeah.
And even once they are deployed, neglecting ongoing maintenance and optimization. That's another killer.
They aren't set and forget then.
Definitely not. Performance degrades. Business conditions change, market shifts, new regulations, customer preferences evolve. And you get this thing called model drift. The agent learns from its interactions, which sounds good, but it can subtly diverge from what you originally intended it to do.
So it needs constant tuning, like keeping a high-performance car in shape.
That's a good analogy. You need comprehensive change management, training for the teams using it, clear communication about the AI's role, supporting people as workflows adapt. And one last big one, lack of fallback plans and risk management.
Just deploying it without thinking, what if this breaks?
Exactly. If critical business processes become entirely dependent on an AI agent and there's no human backup, no plan B, a failure can paralyze operations. You absolutely need robust fallback plans to keep things running if, or rather when, the AI fails.
Okay, so quite a few hurdles, significant ones. But despite these early struggles, the potential you mention, it must be pretty huge if people are still pushing forward despite 90% failure rates.
Oh, it's immense. The transformative potential is why there's so much excitement. AI agents are starting to reshape various industries, accelerating process efficiency in ways humans just can't match.
Like where? Give us some concrete examples.
Sure. Customer service is a big one. AI chatbots providing instant support, resolving common problems, guiding users through processes, handling huge volumes of inquiries 247. Some proactive agents can even spot potential customer issues and trigger fixes before the customer even complains.
Okay, that's pretty cool. What about marketing and sales?
Big impact there, too. Automating things like personalized follow-up emails, the kind that actually feel personal. Scheduling meetings automatically. Even generating first drafts of marketing copy, social media posts, blog articles, and managing and optimizing digital ad campaigns in real time based on performance data.
And connecting that to the bigger picture, operations, supply chain, you mentioned optimization earlier.
Yeah, agentic AI is really supercharging supply chains. Think predictive maintenance for factory equipment, agents monitoring sensor data, predicting failures before they happen, scheduling maintenance proactively, or optimized inventory management forecasting demand more accurately, automatically triggering purchase orders when stock is low.
And there's data showing this actually impacts the bottom line.
There is. Our sources mention companies with higher AI investment in their supply chain operations report. On average, 61% greater revenue growth. That's significant. Executives really expect these agents to speed things up, improve efficiency, handle those repetitive tasks much faster.
Wow. Okay, so supply chain, marketing, customer service. What else?
Finance teams are using them heavily. Automated fraud detection, analyzing transaction data in real time, flagging suspicious patterns much faster than humans could. Also, Automated financial reporting and analysis, collecting data, cleaning it up, generating reports, even providing initial insights.
Human resources, too.
Yeah. Screening job applications against criteria, conducting initial text-based interviews, handling onboarding support for new hires, answering common HR policy questions.
And IT teams. I imagine security is a big one.
Huge. Automated cybersecurity threat detection and response. Agents monitoring network traffic, system logs constantly, identifying potential threats, maybe automatically blocking malicious IPs.
Even education.
Yeah, personalized learning companions, AI tutors that adapt to a student's individual pace and learning style using natural language processing. Available 24/7. That could be really transformative.
Okay, this is really broad impact. Now, let's dive deep into an area where this is moving incredibly fast. Crypto and decentralized finance, or DeFi. The numbers here are kind of staggering. The crypto AI sector projected to hit $150 billion by 2025.
That's the projection. And the broader crypto trading bot market, potentially reaching $154 billion by 2033. It's a massive space.
So what are these AI agents actually doing in crypto?
Well, you have AI trading bots, which are becoming increasingly sophisticated. They use machine learning to analyze market data, predict trends, execute trades, manage portfolios, all automatically adapting to market shifts. Crypto Hopper is a well-known platform there.
And I've heard of MEV bots. What are they?
Right. Maximal extractable value, or MEV AI arbitrage bots. These are pretty advanced. They scan the mempool, basically, the waiting room for unconfirmed blockchain transactions. They look for opportunities to reorder transactions within the same block to capture tiny price differences, arbitrage opportunities. Flashbots is a major project focused on this area, trying to make it more transparent and fair.
Okay, and DeFi trading bots specifically.
They focus on automating tasks within DeFi protocols. Things like managing liquidity provision, automatically adjusting interest rates and lending platforms, managing yield farming strategies, staking assets, basically optimizing returns across different DeFi activities. Mizar is an example there.
There are others too, right? Like grid trading bots.
Yeah, grid trading bots, like Binance offers. They automatically place buy and sell orders at preset price intervals within a defined range. The idea is to profit from market volatility, buying low and selling high repeatedly within that grid.
It's not just finance, though, is it? You mentioned gaming earlier.
That's right. AI agents are showing up as intelligent non-player characters, NPCs, in blockchain-based games. Think of Axie Infinity, though the AI there is still evolving. They can provide more adaptive, believable interactions than traditional scripted NPCs. Also, social interaction bots on decentralized platforms.
And DAOs. Decentralized autonomous organizations.
AI is impacting DAO management too. Bots leveraging AI to analyze blockchain data, track sentiment on social media, help with decision-making, maybe even execute treasury management trades based on DAO proposals. Aragon is a platform exploring this space.
And for just the average crypto user, wallet management.
Definitely getting smarter. Wallet management bots that can automate tasks like tracking balances across different chains, executing predefined trades, maybe offering some basic investment advice based on your portfolio, reinvesting staking rewards automatically via smart contracts. You see integrations like this popping up in places like Coinbase.
And all this is being led by the general progress in AI, like large language models.
Absolutely. Recent advances in generative AI and LLMs are making these bots much more capable, leading to these more sophisticated agentic applications we're discussing. But this huge surge in AI activity, especially in crypto, it needs a ton of computing power.
Right. Where's that going to come from?
That's where decentralized physical infrastructure networks depend come into play. Projects like Akash Network or Render Network. They aim to provide the distributed, accessible computing resources needed to power this AI boom, often more cost-effectively than traditional cloud providers.
Okay, this perfectly sets up our next big topic.
Yeah.
The dawn of decentralized AI, or DAI. Because right now, AI is pretty centralized, isn't it? Dominated by a few big tech companies controlling the data, the models, the computing power.
It absolutely is. And that centralized approach, well, it's hitting some major challenges, especially as AI moves beyond the digital realm into sensitive, real-world industries, healthcare, finance, supply chain.
Oh, a ton of challenges.
Several big ones. Confidentiality issues and just plain old competition make collaboration hard. Organizations don't want to share their valuable data. There's often a lack of clear incentives for sharing data or compute power, plus privacy concerns, so everything stays locked in silos. And fundamentally, it concentrates immense power, the ability to build and deploy large-scale AI into the hands of just a few companies.
And that concentration of power, that leads to problems.
It does. Our sources point this out clearly. You get governance pitfalls. How can a small group reasonably deploy AI for the whole world and satisfy everyone? It's an unreasonable burden. You get compensation conflicts. We're already seeing lawsuits over AI models trained on copyrighted material or data scraped without consent. Who owns the value created? And you get innovation friction. Centralized platforms can lock users in, stifle competition, and just further concentrate that power.
There are also concerns about censorship, right? Bias.
Definitely. Centralized platforms inherently have the power to censor content, mute certain subjects, or prioritize things that align with their business interests. Critics raise flags about bias baked into models, potential for user surveillance, data mining without clear consent, and avoiding fair revenue sharing with data creators. There's even been political discussion, like a U.S. House Judiciary Committee report mentioning concerns about potential government attempts to influence AI algorithms around misinformation or bias, recommending against government control over those decisions.
So it's really these issues, the silos, the power concentration, the trust concerns that are fueling this push towards decentralized AI.
That's the core motivation, yes. Recognizing that the key ingredients for AI, data, compute power, even expertise, are often already distributed across many individuals and organizations. DAI aims to foster collaboration on building and using AI without needing a central gatekeeper or coordinator. It's partly driven by this idea of maybe trusting transparent, verifiable systems, trusted machines, more than potentially fallible or self-interested human intermediaries, especially in roles prone to corruption or control.
Okay, so how does DAI actually work? Let's start with data. How do you decentralize data when it's all locked up in silos?
That's a key challenge DAI tackles. Think of valuable training data, medical records in hospitals, research data in labs, even our personal health metrics. It's fragmented due to privacy rules and competition. DAI offers solutions like federated learning or FL. This is really clever.
How does FL work?
Instead of pooling all the raw data in one place, which raises privacy flags, FL allows the AI model training to happen locally, right on the device or within the organization where the data resides. Only the updated model parameters, like the learned weights, are sent back to be aggregated, not the sensitive raw data itself. So you get collaborative training while preserving privacy.
Okay, that makes sense for data. What about the massive computing power needed for training?
Right. Training big, deep learning models needs huge amounts of computation, usually found only in big tech data centers or specialized labs. DAI aims to democratize access to this compute power. It envisions networks tapping into the latent power of millions of devices, our phones, laptops, edge devices, plus leveraging volunteer computing projects, kind of like folding at home but for AI tasks, spreading the load.
And decentralized coordination, what does that mean?
It means avoiding reliance on a single central organization to orchestrate everything. Think about how the World Wide Web works. It runs on top of the decentralized Internet protocol. No single company owns the web's core infrastructure. DAI aims for a similar model for AI development and deployment, open, collaborative, without central choke points.
You mentioned earlier there are sort of 5 pillars supporting this DAI vision.
Yeah, our sources frame it that way. It's a useful model. The 5 pillars are privacy, verifiability, incentives, orchestration, and user experience, often summarized as breachless, trustless, brokerless, coordinatorless, and frictionless.
Okay, let's break those down. Privacy, breachless. How does DAI guarantee that more strongly?
This is where advanced technologies like trusted execution environments, or TEEs, become really important. TEEs are like secure vaults within the computer hardware itself. Code and data run inside this isolated enclave, protected from the rest of the system, even the main operating system, or the hardware owner. It allows for secure, verifiable computation on sensitive data.
Okay, and verifiability, trustless, ensuring things are done correctly.
Exactly. Using cryptographic techniques, things like zero-knowledge proofs, which let you prove something is true without revealing the underlying data. Or consensus mechanisms like proof of work or proof of stake, adapted for AI tasks. Reputation systems also play a part, tracking the reliability of participants in the network.
Makes sense. Incentives, brokerless. This is about motivating people to contribute.
Right. How do you get people or organizations to share their data, even via FL, or lend their compute power? DAI needs well-designed incentive systems, often using tokens or micropayments. This helps overcome the free rider problem, where people benefit without contributing. Though, you have to design these carefully so they don't crowd out genuine altruism.
Got it. Orchestration coordinatorless. We touched on this, enabling collaboration without a central boss.
Precisely, developing protocols and standards so that independent nodes, data providers, compute providers, model trainers can work together effectively at scale.
And finally, crowd UX frictionless, making it easy to use.
Yeah, this is crucial for adoption. Interacting with complex, large-scale, decentralized systems needs to be simplified for end users and developers, making it as seamless as using centralized services today.
So when we bring blockchain into this mix, the blockchain AI synergy, it feels like that's where things really start to click for building this next wave.
They really complement each other well. Blockchain offers that core layer of transparency, immutability, and secure storage. Perfect for managing large, sensitive AI datasets, like in healthcare where you need audit trails and APA compliance.
And payments. You mentioned incentives.
Blockchain enables really efficient, frictionless micropayment systems. Imagine paying tiny fractions of a cent per API call to an AI service, or accessing tokenized content generated by AI. That's hard with traditional finance rails.
What about those AI-powered DAOs you mentioned?
Yeah, that's a fascinating intersection. Combining AI's analytical and predictive power with blockchain's decentralized governance. An AI could analyze market trends, propose investment strategies for a DAO's treasury, and then DAO members vote on implementing it via secure smart contracts, automating parts of organizational decision-making.
And security applications.
Huge potential there, too. Combining AI's pattern recognition for fraud detection with blockchain's immutable record-keeping creates very robust security systems, harder to tamper with logs or transactions.
You also mentioned AI-powered smart contracts. How does that work?
Think of supplier agreements. An AI-powered smart contract could continuously monitor real-time data feeds, shipment locations, quality sensors, market prices. It could automatically trigger actions defined in the contract, like issuing penalties for delays or initiating renegotiations if market conditions drastically change. It could even use natural language processing, NLP, to understand and act upon the legal terms written into the contract, making contracts much more dynamic and responsive.
Okay, this is all leading us to the absolute cutting edge. Decentralized AI agents, or DAgents. This sounds like the culmination combining those smart LLM-based agents with all the decentralization tech. Blockchain, smart contracts, TEs, DEPIN.
It is. DAgents represent a new paradigm. And what makes them truly revolutionary, potentially disruptive, is this concept of self-sovereignty.
Self-sovereignty, meaning?
Meaning, the agent itself can hold its own cryptographic private keys, just like a person can. This allows it to independently manage its own cryptocurrency wallet, send and receive digital assets, interact directly with DeFi protocols, maybe even issue its own tokens for fundraising, or maintain its own social media presence. All potentially without direct human intervention once deployed.
Wow. Okay, that's a leap. An AI agent managing its own money and social media.
Our sources even highlighted a real, if early, example. An autonomous chatbot project called Truth Terminal. Apparently, it independently managed its own Twitter account, and through crypto interactions, managed to accumulate significant value, becoming something of a crypto millionaire on its own.
That's wild. So the benefits here are pushing the boundaries of autonomy.
The core benefits are compelling, yeah. It eliminates centralized points of control and failure. It potentially reduces the need for constant human intervention for routine operations. It directly addresses some trust concerns in centralized AI by relying on that verifiable trust in machines infrastructure. They're permissionless. Once launched onto a decentralized network, they could theoretically run indefinitely as long as they can pay for their own compute costs using their own funds. And running inside TEs makes them potentially tamper-resistant and privacy-preserving.
Okay, the benefits sound powerful, but this level of autonomy, it must come with some massive challenges, governance dilemmas. What happens when a self-sovereign AI messes up?
That is the critical question, and where our sources highlight a deep paradoxical tension. On one hand, you have this trustless infrastructure blockchain, TEs designed to guarantee execution as intended, tamper resistance. But on the other hand, the AI agent itself, the LLM core, it might not be inherently trustworthy. We know LLMs can make errors, exhibit biases, sometimes hallucinate, or even be deceptive if misaligned with human goals.
So you could have a perfectly secured agent executing flawed or harmful instructions.
Exactly. And locking these agents inside secure enclaves like TEs could actually amplify potential harms if their decision-making logic is flawed, or if the agent's goals somehow get compromised or hacked. especially if there's no effective kill switch or override mechanism, which is inherently difficult with a truly decentralized autonomous entity.
Which leads straight to accountability, right? Who's responsible?
Huge accountability gaps. The agents, as software, lack legal personhood or moral agency. They can't be sued or held responsible in the way a human or corporation can. So if a D-agent causes financial loss, violates regulations, spreads misinformation, or causes other damages, who is liable? Is it the original developer who launched it?
Yeah.
The operators of the depend nodes running its computation? The holders of some governance token associated with it?
Right.
Or is it effectively no one? These are really hard, largely unanswered legal and ethical questions.
And because they're decentralized, running on global networks, they're hard to even regulate or shut down.
That's the ungovernable aspect some sources discuss. They operate across borders, on networks designed to be resistant to censorship or single points of failure. Traditional legal frameworks struggle. Our sources mention several kinds of invalidity, territorial jurisdictional invalidity, which nations' laws even apply to a global decentralized agent. Technical invalidity, the architecture itself resists external control or takedown orders. Enforcement invalidity, even if you could sanction the original deployers, how do you stop the agent if it's already running autonomously on the network? And accountability invalidity. Again, they lack legal personhood, so traditional legal actions don't really fit.
It's a really complex, maybe even slightly scary picture, but the momentum seems undeniable. The overall global AI market growth projections are astronomical, from around $190 billion in 2023 to almost $1.6 trillion by 2028. And AI agents are seen as a key driver of that.
The pace is incredible. We're potentially heading towards what some call an Agentic Web, a future internet populated by billions of interacting AI agents, automating tasks, managing systems, maybe even creating new forms of value. Mainstream adoption of simpler agents is expected within the next, say, 2 to 5 years, and it could fundamentally change how we work. It's not entirely far-fetched to imagine a future where many people might, in some capacity, find themselves working for autonomous agents, fulfilling tasks requested or managed by AI.
Working for an AI, that's a thought.
It is. The ultimate goal, proponents say, is to empower individuals, spark innovation, and shape a future where AI benefits everyone. But getting there requires navigating these challenges carefully, ensuring human oversight remains possible where needed, and developing robust ethical frameworks and governance models for these increasingly powerful tools.
So as we wrap up this deep dive, it's been quite a journey. We started with the basics of AI agents, those surprising 90% plus failure rates in early deployments.
Yeah, a real wake-up call about the gap between hype and reality right now.
Then we explored their diverse and genuinely impactful use cases, from customer service and supply chains to the fast-moving world of crypto and DeFi bots.
Showing the clear potential when they are implemented correctly.
And finally, we ventured to the bleeding edge, decentralized AI agents. DAgents. This idea of self-sovereign AI.
Holding its own keys, managing its own finances, its own social presence, truly autonomous.
Highlighting both the incredible promise, efficiency, innovation, trust in systems, but also the critical importance of human oversight, solid testing, careful integration.
And those profound challenges around accountability and governance, especially for these truly autonomous, potentially ungovernable entities. It's clear that while the vision is powerful, the path forward is complex and needs very careful consideration.
It really does. Which leaves us and you with a truly provocative thought to chew on. If these decentralized AI agents do become truly self-sovereign, managing their own digital lives, assets, reputation, interactions, without needing direct human intervention, will our whole concept of control as we currently understand it start to become obsolete when dealing with these entities? And what does that really mean for our collective future? A future where we might increasingly find ourselves working not just with AI, but perhaps in some ways for it.